All right, number 9. For the points P and Q, find the distance between P and Q. And that's all this notation here at the end means. What is the distance between the point P and Q? And so we've been given some information here, and we're told that the point P is at the ordered pair 4, 4, and that the point Q is located at -1, -5. And since we're finding the distance between these 2 points, I went ahead and wrote the distance formula here on the screens to help us. And even though it wasn't required, it wasn't asked for in the directions, I'm going to go ahead and plot both of these points just so we can visually see what it is that we're solving. So let's go ahead and plot the point P. So 4, 4. So we'll go to 4 on the X, 4 on the Y, plot our point. So we'll let that be point P. And now Q is -1, -5, so we'll go to -1, down to -5. We'll go ahead and plot Q. And now what we're doing is we're finding the distance between these 2 points. So what is that distance? Well, I don't know. Let's find out together. And you can see here that we have the distance equals the radical of y2 minus y1, that quantity squared, plus the quantity x2 minus x1 squared. And based on this notation, y2, y1, x2, x1, we know we're going to be taking these points and plugging them into this formula. And anytime I'm dealing with points and formulas, I always like to label my points to make sure I'm a little more organized so I don't get, hopefully, mess up what points I'm plugging in into the formula. So let's go ahead and we can let point P be our first point, meaning we'll go ahead and label this x1, y1. And if that's x1, y1, then this will be x2 and y2. All right, these are arbitrary, meaning we could have started with point Q and said that point Q was 1 and y1. And we could have said then if these are x1, y1, then these would have to be x2 and y2. So again, it doesn't matter which point you start labeling, it just matters that you're consistent with your labeling, meaning if this is your x1, this has to be y1. This cannot be x1 and this be y2, right? The subscripts here have to match, all right? So we'll go ahead and leave it like that, why not? And now we're going to take this information, plug it in. So let's see what happens. So the distance equals, wow, that's a bad radical, isn't it? All right, let's try again. So radical, y2 minus y1. So 4 y2 minus y1, -5, squared, plus x2 minus x1 squared, x2 minus x1 quantity squared. Notice that plugging in, I'm using parentheses, especially for the y1 and x1, because we want to make sure that our signs, we watch our signs. If you forget to use parentheses, sometimes you may forget that this negative sign has to be distributed, right? And so this really turns into a plus. So whenever you plug in, it's definitely a good idea to use parentheses if you can. All right, let's clean this up and see what happens. So we end up with 4, and when we distribute, we end up with a plus 5 squared, and then plus, and again here 4, we'll distribute this negative through, so we end up with 4 plus 1 squared equals, again, we're just simplifying here, well 4 plus 5 is 9, so we end up with 9 squared plus, and here we have 4 plus 1, that's positive 5. So positive 5 squared. All right, we'll go ahead and simplify again. Well, we know 9 squared is 81. 5 squared is positive 25. And so we end up with, well, 81 plus 25 is 106. And so our distance between the points P and Q, this distance here, is radical 106. If you could break this radical down, you would definitely want to do that. If this was a perfect square, for example, you would certainly want to evaluate that. Don't leave it in the radical. But in this case, radical 106, I don't think we're going to be able to break down. and it's certainly not a perfect square, and so we'll go ahead and leave it in radical form just like this. So again, the distance between point P and point Q for number 9 is radical 106.